One of the most common questions in any Calc 1 class is this, what we're looking at right here, where they want us to find the equation of the tangent line to a given graph at a specific x value. The secret to this is really, this is the same process you've been doing since algebra. You need to find the equation of a line. It just so happens to be the very specific tangent line that we find using derivatives. So whenever you needed to find the equation of a line previously, you wanted to find first a point on the graph. You need an x and a y. And then the second thing you need is the slope of the graph. Well, in calculus, you find the slope using your derivative equation. That's really the newest part, really the only thing that changes in your process between calculus finding the equation of a line and algebra finding the equation of a line. And then the third thing you want is your point slope form. Different people memorize it different ways. I like to memorize point slope form as y equals m times x minus x1 plus y1. You might as well move this y1 over to the other side to begin with, because that's what you're going to do anyways. So I've never understood why they want you to memorize this with y1 on the other side. But this is point slope form just like any other point slope form. So it'll get us what we need, and it saves us a move of algebra. So we have to go through this process here. Let's do it. Step one, we're going to go find the point off of the graph. So they tell us that we have an x value that's equal to 1. Well, to find the y value, we just need to plug that x value into the equation that we found. So our y value is going to be f of 1. We take 1 and we pop it into this equation. So everywhere we see an x, so 5, we put a 1 in parentheses to the fourth, plus 7 times 1 to the negative third, minus 10 times 1. And then out of there, cleaning that thing up, you pop it into your calculator, you're going to end up with 5 plus 7 is 12, 12 minus 10 is 2. So we end up with f of 1 equals the square root of 2. So that is our y value. So at this point in our process, our x value is 1, our y value is our square root of 2. We have our x1 and our y1 that we need to plug into our point slope form. So now we're just going to go and we're going to get into our calculus side of life. So the calculus is going to give us our slope. Our m that we need is going to come from our derivative equation. So specifically in this one, we need to find out what is f prime of 1, because that's the x value that we care about. Well, of course, that means we got to go find the derivative of our given equation. So the equation we were given to work with is f of x equals the square root of 5x to the fourth plus 7x to the negative 3 minus 10x. Before we're even allowed to get started on this derivative, we got to rewrite that square root. Anytime you see a root in a problem, that's always going to be a rewrite that you need to do. This is our power over root rewrite. So if you have x to some power inside a root, you rewrite that as x to the power divided by root. So here we magically have this unwritten 1 around that entire chunk inside our square root, and then it's a square root, so we have an unwritten 2. So doing just our rewrite on this, we end up with 5x to the fourth plus 7x to the negative third minus 10x, and all of that is to the power of 1 over root of 2 power. So we do our rewrite. Now what we have to do is go find that actual derivative. Well, the derivative on this one, if we look at it, that's definitely more than a bunch of stuff being added and subtracted, so we know we got something more than a power rule. And what we're looking at here, when you've got something inside of a power like this is a classic chain rule setup. Whenever you got a bunch of stuff inside a set of parentheses raised to a power. My chain rule saying that I use goes d in times d out. The derivative of whatever is inside those parentheses times the derivative of the outside. So really the outside is usually just going to be a big power rule. So coming through our derivative and applying that rule for ourselves, we get f prime of x equals we go find the dn, the derivative of whatever is inside the parentheses. So that is going to be all of that stuff right there. And that is a bunch of stuff being added and subtracted. So our in portion is going to be a power rule to get our derivative. We bring the 4 down. 4 times 5 gets us 20x. Subtract 1 from the power gets us x to the third. We bring the negative 3 down. Negative 3 times 7 gets us negative 21x. Subtract 1 from the power gets us x to the negative fourth. You got an unwritten 1 on that x at the back there. So 1 times negative 10 gets us negative 10. Subtracting 1 from the power gets us x to the 0. And as we talk about all over the place, anything to the 0 power is always 1. So 1 times negative 10 gets us negative 10. So that's our dn from our chain rule. Then our derivative of our outside is just going to be a big power rule. You're going to bring that power down in front. So we bring the 1/2 down in front. You're going to leave alone all the junk you already took the derivative of, and then you subtract 1 from the power. So 1/2 minus 1 gets us negative 1/2. And then all that stuff that was inside there, it just stays exactly the same. We handled that derivative with our dn. So there is our slope equation. That's what we found. Remember, derivatives are just a slope equation. So we know our formula for finding the slope. And now what we have to do is go find the specific slope that we care about. We want to know what's happening at 1. So f prime of 1. We're just going to take, and everywhere you see an x inside that equation, you're going to plug in 1. So we get 20 times 1 to the third minus 21 times 1 to the negative fourth minus 10 times 1/2, and then 5 times 1 to the fourth plus 7 times 1 to the negative third minus 10 times 1, all that to the negative 1/2. Cleaning this all up, what you're going to end up with out of this whole thing, pop it into your calculator, do it a chunk at a time by hand. We're going to end up with negative 11 over 2 square root of 2. So whatever you got to do to get to that answer, that is your m now. That is your slope for the equation of your tangent line. So at this point, we have the second part of what we need. We have the slope. So we're done. We have all the pieces of the puzzle that we need to put together our final answer. So to get our equation of our tangent line, step 3, we're going to plug everybody into our point slope form. Y equals m times x minus x1 plus y1. So we get y equals m, which is the slope that we found using our derivative. So negative 11 over 2 square root of 2 times x minus x1. That was the point that we've been working with. Our x value is 1, plus y1 is the square root of 2. And so that is your final answer, unless somebody wants you to simplify it a bit more, which would just be, distributing this through and then combining your like terms. But most of the time, they just want the equation of the tangent line. That's the equation of the tangent line. That's your final answer. But the process for this is always the same as finding any equation of any line. Find the point, find the slope, which is where the calculus comes in using your derivative, and then pop your points and your slope into point slope form. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.